In this video, I'll be talking about the charges on an insulator and a conductor. So, conductor is a material in which there are ocean of electrons, many free electrons, which can flow from one point or one region to another region. That's why what you call the conductor. That means it can easily flow. And an insulator is a material or is an object in which the electrons cannot flow easily from one region to another region. Let me give you an example. Let's say you have an insulator like a paper, cloth, glass rod, or silk, and you have a metal sphere just like a copper, aluminum, iron. Now, these two are initially uncharged. Now, if I rub against each other, then the sum of the charges might transfer from one object to another object. So now we're rubbing against each other. So what is happening when we, after rubbing, now let's say the electrons are now transferred from the metal to the insulator. So the insulator becomes the negatively charged. And now let's say it does have the 10 electrons and the metal sphere has the 10 protons, 10 extra protons in comparison to the electrons. So that means it does have the excess of electrons and it does have the excess of protons. Now let's say on the metal sphere, these protons are not localized. Now once it gets charged, it redistributes itself over the entire surface. If it is a sphere, each region becomes uniformly charged. The charges are not localized at only one region or one place on the metal sphere. Now it becomes uniformly distributed on a metal. But now on an insulator, these charges, the negative charges, are localized. That means it remains in that region. It doesn't move to the other region. Okay. So these are the main differences between the metal and the insulator. If a metal is charged, the charged object moves freely and redistributes itself over the entire surface. But whereas on an insulator, it is mostly localized to the area where it is charged. Okay, so that's what I'm saying is written here. The charges are more localized in insulator, whereas in metal, charges flow from one region to another region. So the one idea is, so these positive charges repel against each other and they try to move to the maximum distance as possible, and the maximum distance is that it moves uniformly, or the charge redistributes itself uniformly over the entire surface. But in case of insulator, these electrons are still repelling, but it cannot flow easily into the insulator, so they are more localized in case of insulator. Okay, so that's it on the charges. How does the charges behave on an insulator and a conductor?